Have you ever looked at a tiny grain of sand and wondered what it's made of? What if you could zoom in, past the molecules, right down to the very building blocks of matter itself? For centuries, this was a question that baffled the greatest minds. But then, a giant of science came along, a man who didn't just look at the universe, he fundamentally changed how we see it. His name was Niels Bohr, and this is his incredible story. Our story begins in Copenhagen, Denmark. In 1885, Niels Bohr was born into a family that was practically buzzing with intellectual energy. His father was a renowned physiologist, and their home was a frequent gathering spot for scientists and thinkers. Imagine growing up with dinner table conversations about the latest breakthroughs in science. From a young age, Niels and his brother Harold, who would become a brilliant mathematician, were encouraged to question everything, to explore, and to think deeply. This environment wasn't just nurturing. It was the perfect launchpad for a mind that would soon travel to the very edge of reality. After excelling at his studies in Copenhagen, a young Bohr won a scholarship to study in England. This was a pivotal moment. He first went to Cambridge to work under J. Thomson, the man who discovered the electron. But Bohr, ever the bold thinker, found himself disagreeing with some of Thomson's ideas. So, he made a move that would change the course of physics forever. He went to Manchester to join the laboratory of Ernest Rutherford. Now, Rutherford had just made a groundbreaking discovery. By firing tiny particles at a thin sheet of gold foil, he realized that atoms weren't just plum puddings of positive charge with electrons stuck in them, as Thomson believed. Instead, Rutherford proposed that an atom was mostly empty space, with a tiny, dense, positively charged nucleus at the center, and electrons orbiting it like planets around the sun. This was the famous planetary model of the atom. It was a brilliant leap forward, but it had a massive, glaring problem. According to the classical physics of the time, an orbiting electron should be constantly radiating energy. As it loses energy, its orbit should decay, and it should spiral into the nucleus in a fraction of a second. This meant that, according to the best science of the day, every atom in the universe should instantly collapse. But clearly, they don't. The chair you're sitting on, the air you're breathing, you yourself, were all remarkably stable. Physics was at a dead end. This is where Niels Bohr entered the scene. He looked at Rutherford's elegant but unstable model and saw not a failure, but an opportunity. He realized that the old rules, the laws of classical physics that govern our everyday world, simply didn't apply in the strange, tiny realm of the atom. A new set of rules was needed, and Bohr came up with them. He made a revolutionary leap of faith, a proposal that was as bold as it was bizarre. He suggested that electrons could only exist in specific fixed orbits, or energy levels, around the nucleus. Think of it like a staircase. You can stand on the first step or the second step, but you can't hover in between steps. For electrons, these orbits were the steps. While an electron stayed in one of these special orbits, it didn't radiate energy, and it didn't spiral to its doom. It was stable. But wait, it gets even weirder. Bohr then said that an electron could jump from a higher energy orbit to a lower one. When it did this, it would release the extra energy, not as a continuous wave, but as a single, discrete packet of light, a photon. The color or frequency of this light was determined by the size of the jump. A big jump meant a high-energy blue photon. A small jump meant a low-energy red photon. This beautifully explained why different elements, when heated, glow with specific, unique colors, their atomic fingerprints. This was the birth of the Bohr model of the atom, and it was the first crucial step into the world of quantum mechanics. This idea was radical. It was like saying a planet orbiting the sun could only be at Mars' distance or Jupiter's distance, but nowhere in between, and could instantly teleport from one orbit to another. It broke all the classical rules, but it worked. It explained experimental data that had left other scientists scratching their heads. For this groundbreaking work, Niels Bohr was awarded the Nobel Prize in Physics in 1922, at the young age of 37. But Bohr wasn't one to rest on his laurels. He returned to Copenhagen and founded the Institute for Theoretical Physics, which we now know as the Niels Bohr Institute. This place became the global headquarters for quantum physics. It was like the Jedi Temple for physicists. The brightest young minds from all over the world, Heisenberg, Pauli, Dirac, flocked to Copenhagen to debate, argue, and collaborate with Bohr. The atmosphere there was legendary. Bohr fostered a spirit of open and often intense debate known as the Copenhagen spirit. He believed that progress came from challenging every assumption, from wrestling with paradoxes, until a deeper clarity emerged. His famous debates with Albert Einstein are a testament to this. Einstein, for all his genius, was deeply unsettled by the weirdness of quantum mechanics, famously stating, "God does not play dice." He couldn't accept the inherent randomness and probability that the new theory introduced. Bohr, on the other hand, embraced it. He developed his principle of complementarity. This idea suggests that things at the quantum level can have seemingly contradictory properties that are both true, depending on how you measure them. An electron can be both a wave and a particle, but never at the same time. It's like a coin. You can see heads or you can see tails, but you can't see both at once. They are complementary aspects of the same reality. These Bohr-Einstein debates were some of the most profound conversations in the history of science, pushing both men and the entire field of physics to a deeper understanding of the universe. As the world lurched towards World War II, Bohr's life took a dramatic turn. Living in German-occupied Denmark and having a Jewish mother, he was in grave danger. In a daring escape in 1943, he was secretly transported to Sweden aboard a fishing vessel. From there, he was flown to Britain in the empty bomb bay of a Mosquito bomber. The pilot forgot to give him an oxygen mask, and Bohr passed out from the high altitude, nearly dying before they descended to a safe level. He eventually made his way to the United States, where he was brought into the top-secret Manhattan Project, the effort to build the first atomic bomb. Working under the alias Nicholas Baker, Bohr was less involved in the technical design and more of a senior consultant. He was horrified by the weapon's destructive potential. More than anyone, he understood the immense power that was being unlocked. He spent the rest of his life and career advocating for international cooperation, peaceful applications of atomic energy, and openness between nations to avoid a nuclear arms race. He believed that the same science that created the bomb could, if shared openly, unite the world. Niels Bohr was more than just a brilliant scientist. He was a philosopher of nature, a mentor to an entire generation, and a man who believed knowledge should serve humanity. Bohr didn't just explain the atom. He changed the way we think about reality itself. And his legacy isn't trapped inside a textbook diagram. It lives in the world around you, in every computer chip, every laser, every medical scanner, and every technology built on the foundations of quantum mechanics. Bohr opened a door to a new kind of reality, and even today, we're still walking through. Thank you for joining us on this journey into the mind of a true giant. And if you enjoyed this episode, don't forget to hit the like button. It genuinely helps the channel grow and reach more curious minds. Also, if you want the full story of how our view of the atom evolved, make sure to watch the previous videos in this series. From the first cracks in the unbreakable atom, to the discoveries that led directly to Bohr's revolution. Subscribe to Past Minds, because the next mind that changed everything might surprise you.